Hey everyone! In this video, we're going to continue on with our ways of proving triangles are congruent. So far we know that if we have side, side, side in two different triangles, then they would be congruent to each other. The same goes for side, and angle, side, angle, and angle, angle, side, which could also be side, angle, angle. But there's one method remaining, and we started to talk about it in class. So this one final way is actually going to be HL. And we're going to get there first. So we talked about in class briefly how side-side angle was not a way to prove triangles congruent, because if we have one example and only one example that exists that shows that they aren't congruent every time, then we can't use it as a proof. So basically we've shown why all of our proofs have always been true. But also, just as a little thing to think about, side-side angle. If you look at that SSA, and if you read that to yourself backwards, now hopefully in your own head, you might see something that kind of stands out. You don't want to call someone grading your Regents exam an angle side-side. That's not okay. And even though we know that's not something we want to do, we're just going to look at why. So we have this link from Math Open Ref, and we looked at it briefly in class. But here, if I pull this up, basically what I'm looking at here is I have two triangles. If I start this way, I have the angle at A and P, the sides AB and BC to PQ and QR. So I know I have angle side side. So the way the picture looks right now, this would work. Those triangles would be congruent. However, when I show the other triangle here, now I still have angle side side, but these triangles are not congruent. So all it takes is one example to show that they wouldn't be congruent every time. We can't use it as our reasoning. So unfortunately, we can't confuse this with side angle side. Notice the angle's not in between the two sides. But there is a way around this. So you could go on to Math Open Ref and play with it. But I was talking about HL. So HL could work, because now here, if we have an angle that was a right angle, and then we have a side, this is going to work every time. Right? Bear with me, my computer's not really going with it so nicely. We'll come back to that in a sec, but let's go look at our lesson now. So let's say we had a right triangle ABC, where C is the right angle. Now this is separate from our example here. So triangle ABC, where C is the right angle. So it doesn't matter where I put A or B, because either one would be fine. AB is 5, AC is 3, and we want to find the missing side. So right now, if you look at this, here I have an angle, I have a side and a side. So if I'm trying to show why HL would work, if I had another triangle, and I could just imagine it for a second, we would have that angle, this side and this side. Now, angle side, side, okay. We know it doesn't work every time, but let's see how we know what that missing piece would be. In this case, if we wanted to find BC, remember, when you're missing a side of a right triangle, we can use Pythagorean theorem. Now remember, Pythagorean theorem is a squared plus b squared is equal to c squared, where c is the hypotenuse, the biggest side, the one that's across from the right angle, and a and b are the other two sides. Doesn't matter which one we use for which. So we could plug in here. We would have x squared plus 3 squared equals 5 squared. And we'd be looking at x squared plus 9 equal to 25. We would get x squared equals 16. And when I take the square root of both sides, x would equal 4. So no matter what, if I have two sides of a right triangle, I can always find the third side. And it's always going to be congruent to some other right triangle with the same two sides. The thing here is that you can have angle side side work if there's a right angle. So it will only work for a right angle, which means we call this hypotenuse leg. Okay, so remember, The biggest side is the hypotenuse, and leg stands for either of the other two sides. But if the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and leg of another, then the two right triangles are congruent. So that being said, in the diagram shown, we have AC intersects DE at B, and AC is perpendicular to DE. B is the midpoint of ED. Prove triangle ADB is congruent to CBD. Okay, so we automatically know to set up our statement and reason. That's the first thing we're going to do. I could write AC intersects DE at B and all that, but I see the intersection. I'm going to skip around and kind of just cover some important things like AC is perpendicular to DE. B is the midpoint of ED. And AD is congruent to CE. So all of that's just part of my given information. So that's how we start as given. I'm going to go and highlight my two triangles. I want to prove that ADB is congruent to CBD here. Oh, sorry, this is supposed to say CEB. Okay. So that being said, when I look at this here, we know that AD is congruent to CE, right? It was in the given. So we already have the hypotenuse, but we can't have a hypotenuse if we don't know it's a right triangle. So we first have to show that it is a right triangle. So here, I can show it's a right triangle, right? I have angle, and I can kind of label this in here as 1 and 2 if I want to. I could write it out as angle ABD and CBE, but either way is fine as long as your picture is marked. Angle 1 is congruent to angle 2 because perpendicular lines form congruent right angles. So I have those right angles. I have the hypotenuse was given. And then I have here the midpoint of B is the midpoint of ED, right? So we know a midpoint cuts in half. So we get those two pieces together. So EB is congruent to BD. Okay. Midpoints cut in half. Or midpoints create two congruent segments, whatever you prefer. But then I'm good now. So I know by just looking at one of these pieces, I'm spelling out angle side side. We can't do that. If you ever see that you spelled out angle side side, we have to hope it's a right triangle. And in this case, we showed it was because we had two congruent right angles. So we know we're dealing with right triangles only. So my triangles ADB and CEB, remember we're fixing that typo. That is congruent by HL. So HL we only use if it's a right triangle. It's the only time we could use it. We never try to use it in any other case, but we only use it as the last resort. Like we prefer all the other ones to HL, but if you end up spelling out angle side side and we don't want to do that, then we hope that it's a right triangle because then it's safe because then we use HL instead because you have the right angle that made it a right triangle. You have the hypotenuse that's across from the right angle, and you have the leg that's either one of the other two sides. Okay? And once I show that these two triangles are congruent, then I know all their parts are congruent, right? So A and C would correspond to one another, angles D and E would correspond to each other, and AB and BC would correspond to each other. So we know all the corresponding parts. The sides and the angles is what I mean by the parts. And they're congruent. Okay? So all the corresponding parts, the sides and the angles are congruent. Okay, now here we've got one of these ones that had the overlap again. We know we're doing our statement and reason first. Our given is always where we start. PQ's congruent to SR. QT is perpendicular to PR. SV is perpendicular to PR. And QT is congruent to SV. So there is a lot going on in this picture. This is definitely one where I would recommend you highlight because there's a lot going on. Okay, we know PQT is over here. So we have that first one, and we have our second one of RSV. Okay, so I don't care about anything else going on in this picture. I'm going to go through the given again and see, okay, we have PQ congruent to SR, which is great. And we have QT congruent to SV. So we already have two sides. Okay, so we have two sides already. We need to see what else we can do. Remember, perpendicular by itself does not count as our check because we might know what it means, but we have to be specific. We're treating whoever's grading it like our test, like they're the dumbest person that could be grading it. But once we see perpendicular, we should know QT and PR meet here, and SV and PR meet here. So I'm going to label those 1 and 2. Otherwise, I would have to write out the three angles. Like I couldn't say angle T or angle V. There's too much going on over there. But angle 1 is congruent to angle 2 because perpendicular lines form congruent right angles. And notice, if I look at my picture, that angle falls outside of the two sides. It's not in between them, so it's side-side angle, aka it's angle side-side problem. We don't want that. Lucky for us, because we said it was a right triangle, like we found a right angle, then we're okay to use HL. So basically, the only time we really use HL is if we spell out angle side-side, but it only can happen if the triangle is a right triangle. And you could even make a step in here like saying that the two triangles are right triangles because they have right angles. But as long as you mention that there's a right angle, that part's pretty much assumed. If you're nervous, though, you can 100% take a step in between and write PQT and RSV. The triangles are right triangles because they have a right angle. And then you do this congruence. So anytime we spell out angle side-side, HL is just really there for the rescue. So it only works if it's a 90-degree angle, but it saves us of that try to not call any of our graders an angle side-side. Okay. Last one here. So we have the given set up for us. We have AF congruent to CD. We have AB's perpendicular to BC, and we have DE's perpendicular to EF, and we have AB's congruent to DE. So notice we talked about this, a question like this in class. We have these two triangles, and they overlap, but AF and CD are not enough for a check because you'll see, as I just highlighted, that that's only a small part of the triangle. Something you can do if you're stuck is redraw these pictures just so you get a better visual. Like if this one's F, E, D, right? We knew ED was good. And then A, B, C. So right now we only have one check. We have one side. So we only have one side in there. Now, with that being said, we can get it and we have it set up for us. So really, if I'm looking at this next piece, FC congruent to FC, if I see anything that's just congruent to itself, that's my reflexive. And that should make sense because look, FC's overlap blue and green there. So they're both overlapping. Okay, now what I want to do is add those congruent pieces together because I'm trying to add them along A to C and F to D. So that way I have the two smaller pieces to add up to the big piece for the full side. So I'm going to add them by taking AF plus FC, and it's congruent to DC plus CF. So I'm just taking the two smaller pieces along the blue first, so AF and FC, and then DC and CF. So I added those up together. And then if I combine those two pieces, like AF and FC, add them together, you get AC. Same thing on the right side, the DC plus the CF, they add up together to get FD. This is your parts add to the whole. Okay. And now here, that means I would have AC and FD. So now I have two sides so far. So there's still one piece missing to finish this off. Okay. I still haven't said anything about this triangle having like another side or an angle or anything, but we see perpendicular. So we should automatically know what perpendicular lines do at this stage of the game. AB is perpendicular to BC. DE is perpendicular to EF. So you can label one or two on either one of these triangles. These happen to be by themselves, so we can just say angle B is congruent to angle E because perpendicular lines form congruent right angles. And now there's my last piece. Now if I look at this, the angle's not in between the two sides, so it would be angle side side. We don't want that. So because it's a right angle, it saves the day, and we get HL. Okay. And we want just have one little follow-up at the end there. Is A congruent to D, the angles? Write it as a statement and reason. Well, yeah, of course they are, right? Because we've already proved the triangles are congruent. So angle A is congruent to angle D. And we'll just explain our reasoning, right? The same thing as before. Corresponding angles in congruent triangles are congruent. Okay, so once I prove the triangles are congruent, I know all the angles and all the sides are going to map onto each other as long as they correspond to one another. But really the big idea here is HL can be used, but we only use it if we're setting up a picture of angle side side. So angle side side doesn't work every time. It only works when you have a right angle. So that right angle is enough to push us forward. And once we know that there's a right angle, then we can get HL. So it's still like 3 checks if you think about it, because that angle has to be a right angle. So we're knowing that it's a right angle. A hypotenuse and a leg are the two sides. So it is still like we're looking for 3 things in here, but we only use HL when we come to that place where we don't have, or when we have a right angle. Now remember, that doesn't mean every right triangle moving forward is getting HL. We've done side angle side with right triangles. We've done angle side angle. We've done angle angle side with right triangles. They all were able to be proved with the right triangle. We only use HL if it spells out angle side side and we have a way to get that we're fixing it. So we should never write angle side side or side side angle. Writing it in the reverse way doesn't make it better. Okay. And let's just see if we can look here. Oops. Not my calculator, but I was trying to use this before too. You can play around with this here. We know that 2 right triangles are congruent if the hypotenuse and one corresponding leg are both equal. Really,